What is going on, everybody? Welcome back. This is video 2 on network programming, and in this video we're going to be taking a deep dive into the server code that we saw in the last video. We're going to pick it apart and really look through all the different components of it. But before we do that, let's talk about what we did on Azure. So in our last video, we created this resource group and we added a virtual machine called the Alpha VM. I am going to go ahead and delete these components of this resource group and recreate this from scratch. If you are going to be continuing with what you created in the last video, then please go ahead and skip ahead to this timestamp, which should be appearing on your screen now. It's also in the description. But otherwise, if you did not see the last video and you are brand new to this series, I'm going to repeat the steps from the last video. And the reason for this is because, well, cloud computing honestly is not that hard. It is so easy, and I just want to really demonstrate that, yeah, this is sort of in the background of our series. So I'm going to remove all this. I'm going to type delete, and we're going to go through the process of creating this again. From scratch. So we'll come back when this is done. Okay, we are back, and this is now an empty resource group. And before we jump into the Quick Start Center, we're going to walk through the process of creating a virtual machine server out there on the cloud, and we're going to put our server code on this virtual machine. Before we jump in there, let's take a look at cost management. So I haven't been deployed on Azure for very long. This has been running since I think basically 2 weeks now. My server has been running. I can't get the calendar to come up. So yeah, maybe March 10 was when I really started to run a virtual machine, and I sort of just left it running 24/7. And I even started a second virtual machine in a second resource group for these tutorial videos. And we are coming up on what, like 20 days, 30 days? No, 20 days. And they're charging me about $8. So that is 1 hour of a minimum wage employee. So I know it's behind a price barrier, but honestly, it is so inexpensive. Anybody can do this that has a credit card, and it's going to be very cheap, and there's going to be a lot you can learn from this. In terms of what other things cost, this is pretty inexpensive. So that might turn some viewers away, in which case there is options for you. You can run the server and client code locally. But part of this series, I do want to get into some of the other features of the cloud, and I do want to, yeah, it's for how much it costs, it's a great platform to learn. You look at some of the other options out there in terms of actually learning this stuff, and it really isn't that bad. Okay, enough said about that. Let's go back to home. So I'm logged in here. I'm just going to go to Quick Start. We're going to go to Projects and Guides, and we're going to deploy a virtual machine. We're going to get a Linux virtual machine. I'm going to go faster through this time since I did this in the last video. So subscription, that is going to stay the same, but resource group, this is where you can sort of put your different deployments into groups. So you can sort of think of it like a folder. So if you have this project going on, you put it in this folder. You have that project, you put it in that folder. I'm going to use the same resource group from last time, but you can create as many as you like. I'm going to call this Alpha VM again, just for continuity. You can pick your region. So for me, West US is the closest. Availability zone, we're not interested in this for this video. So I'm going to turn that off. Security type standard is fine. I'm going to stick with Ubuntu. I'm going to go with the 20.04. We're not using ARM64 in this video. And then the B1LS is the cheapest at the time of recording this video. So we're going to use that one. SSH public key is good. Username, I like to use ckirk. And I am going to use alpha ckirk alpha VM as the key pair name. SSH enabled, looks good. We're going to go to disks. We do not need premium disk. We're going to go to standard hard disk drive. I'm going to get rid of that pop-up. And platform managed key is fine. We're going to go to networking. All of this is fine, left as the default. Everything's looking good. Go next. Go next. 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 Everything default looks good. Review and create. And we're good to go. Let's go ahead and click create. We do need to download and save this private key. We're going to get this into, I'm using Windows Subsystem for Linux, but basically you're going to need to save this off because later when you actually try to SSH, which is how you log into this virtual machine on the cloud, you need this key in order to authenticate. So we'll click download, and you can't see what just popped up on my screen, but I'm saving this into a folder right now. I'm on a Windows PC. I will stick it, go back. VM. Okay, same name as last time. So I'll save it here. I will overwrite since I deleted the last one. Okay, we will come back when this is done. Okay, we're back and the deployment is complete. Let's go to the resource group. And here is our machine. We have a public IP address and everything is looking good. DNS name not configured. We're not going to need that for this video. Let's hit P5, or sorry, the F5 key to refresh the page. And okay, that little message went away. Everything's looking good. And that's it. So this IP address, our SSH key, that's everything we need to get started. Okay, so let me just show you how we can use that SSH key. Okay, so File Explorer here. I saved off my key here, and I'm going to hit copy, and I'm going to go into my Linux. Under this PC, there's a Linux, and then I'm going to go into 22.04, home, Seekirk, and I'll put it into SSH, and that's where the last one was. I'm going to paste, and we're going to replace. I don't have permission. Okay, let's ls.ssh. We're going to rm Seekirk. Whoops. .ssh Seekirk alpha VM pem. Yes. Okay. And I think we are good to paste now. So if I refresh, that's gone. If I paste, we're good. That was successful. Now if I ls.ssh, it's back. Cool. Let's switch back over to Azure. And if I click this connect button for SSH, we just have to, it's going to check to make sure you can even do this. Just sort of a helpful thing. But just follow these steps. So we need to run this command on our key. So let me copy this command. And let's head over here. And let's erase this with our key name. Cool. We'll come back over here, and now we need to run this command to get connected. So I'll paste that in there. We need to replace this with what our actual private key path is. There it is. Hit enter. We'll say yes. I'm going to type clear. And we are logged in. So now we're Seekirk at Alpha VM. If I do host name, we're on Alpha VM. So this is a totally different computer that I'm remotely logged in on a terminal. And it's on the cloud. And we are ready to go. So honestly, the steps to get a Azure virtual machine set up really was not that bad at all. Okay, we are all set to go. So I have this terminal here that's connected to our Alpha VM the cloud server. And I have this terminal, which you'll notice the color scheme kind of changed a little bit. But this is CKirk on my Kirk PC, which is my personal computer at home. So this will help you know when I'm switching between the server and the client as we work through this example. The next thing to know is nothing. I think we're ready to start diving into the code. So I'm over on my local PC, and under repos, I have all of this code on GitHub. I have this network programming repository. Link is in the description if you want to get your hands on the code yourself. I'm going to type code network programming. Hit enter. That will open Visual Studio Code up. F11. And we have video 1. The code from video 1 is here. So let's go ahead and close the code from video 1. We're going to make a copy of video 1 and paste it. And we're going to call this video 2. And we're not going to be focused on the client. The client will remain the same. We're going to be focused on the server. So here's the server code. I'm going to install that update later. And the next thing we're going to do is we're going to gut out main. So we're going to be taking out all the code here, and we're going to put it back together again. So another thing I want to point out, I am over here on our local PC. I've already done this step. The command is in the description, but we're going to take a look at how to actually use the debugger, gdb. So this is the command to run. I'll hit enter. It's going to tell me that I already have this installed. So gdb is already on the newest version, and it's already installed. But go ahead and run that command, because we're going to be using that in this video. So there's two objectives for this video. Number one, we'd like to be able to understand how all this code was created. And number two, I think we can improve on this code and make it better. So one way we can make it better is by making our code more portable on lots of different systems. And so we're going to write our code in a style that makes it more easily portable between operating systems and really leverage the POSIX standard. And I've done some research on things that we can use to do that. Okay, and let's go ahead and start off with an initial commit here. Okay, so let's talk about what's the first thing we did in the last video. The code that we were given from Geeks for Geeks. Well, the first thing they do is they create a socket. And the way they create this socket, they are using, well, they're providing these flags to the socket, and they're getting a file descriptor. And then from there, they're sort of configuring the socket to what they want it to be. And then from there, they are creating a way to bind. We can do a much better job of doing this, a much more automated, more system agnostic way, a more portable way, if you will, by using a very special function. I'll pull it up on the screen now. By using this guy. So right now I am on the Linux manual page, and we're looking at a function that we can use that's provided by the system called getAddressInfo. And it tells us the name, it tells us what this does, and it also gives us a wonderful example down here with all the includes of a server program. So we're going to kind of follow along with what this guy does up until a certain point where they're doing something different than what we are, and we want to do what we did in the last video, but do it better. So with that said, let's start to work through this. But before we do that, I just want to show one other thing that might be a little bit interesting. So this get address info is a function from the Linux Unix system programming manual page, Linux manual page. And this is created by the team that is responsible for the Linux man pages project. This is an HTML rendering. I like to work out of the HTML rendering just because it's going to give me the latest version of everything. This is the most up-to-date version that you're going to get. But here's the interesting thing. If you're not familiar with man, here's the man command in Linux for manual. And we're going to do man on get address. I'm not even going to finish typing it. I'm going to hit tab and it auto-completes. And I hit enter and it takes me to a screen that looks like this. And this is the Linux Programmer's Manual. And this is the same information that is provided on the HTML pages. So they're just giving you a HTML mirror of those same pages. I'm going to increase the font size here. So it's the same information. So if we go down to description, it's the same. Description, given a node, and service, it's all the same stuff here. So if you have anything that's running the Linux kernel, you're going to get this. And this is all having to do with following that POSIX standard like I talked about in the last video. So Linux supports the POSIX standards. If I scroll down here, there's a lot of information. This tells you absolutely anything that the operating system will do for you. So this is conforming to POSIX.1-2001 and POSIX.1-2008. And let's scroll back up and see if there's anything news or noteworthy about what this function does. So this function very simply will return a structure, a address info structure, which contains an internet address that can be used in the bind function or the connect function. So this is a function that makes it very easy for us to do that. It is reentrant, and it also allows programs to eliminate the IPv4 versus IPv6 dependencies. We're going to be talking about this in upcoming videos. We're not going to get too much into it today. So this is good. We're making our code more portable, whether it's IPv4 or IPv6. This is a function that's going to sort of do it all for us. And it gives us a single interface to do that. We're going to go down to examples. So let's check our header files and see if we're missing anything. We're going to head over to our VS Code and go to video 2. So I'm going to make some space. We already have stdio, sys types. I don't know if we're going to need that. stdlib, stdio, we have those. I'll move them down here. I'm holding down the Alt key and using the up and down arrow keys to move those like that. UI, std, we already have that, so I'm going to remove that. String, we already have. I have that right there, so let's move that down. And sys socket, we already have. And netdb we are going to need. And it looks like we don't need inet, so let's get rid of inet. Okay, this is looking pretty good. Let's go ahead and take off this comment here at the top. Okay, that's looking good. Port 8080 is fine. Okay, let's jump back over to the example. So they're doing this buff size. We'll come back to that. Let's jump right in. So the very first thing they do is they create a struct called addrinfo, called hints. And then they're making a couple of pointers and a couple of integers. And then they're going to make a sock address storage. We'll come back to that. Yeah, they're pretty much putting everything up here at the top. So let's get past all of their defines and focus on what it is that we need. We're not going to take command line arguments, so we're going to skip that. Now this memset, this is what okay, so we're immediately working with this hints variable. allow IPv4 or IPv6. Yeah, so we need this hints variable, and we're going to start working with that first. Paste that in. And immediately we're faced with this problem here. Address info incomplete type is not allowed. So in order to fix this problem, a couple of things were helpful for me. Number one was I watched these videos, link is in the description, introductory videos for C++ on Visual Studio Code. This sort of gives you an overview of everything that your Visual Studio Code extension for C++ programming and C programming can do for you. We are using GCC on Linux, and it's pretty informative. So this is in the description. I do recommend giving that a watch. This link here is also helpful for me. This GitHub answer here is exactly what we need. Link is in the description if you want to go look at this whole thread. But basically, under the C++ properties, we need to add this define to our compiler. So I'm going to hit Control-Shift-P and click, and I'm going to go to C++ Edit Configurations User Interface, which brings us to this screen here. And we're not going to change that. We are using GCC, so this stuff was already figured out for me. As we head down here, there is going to be a one called defines. Add one per line, so we're going to add that in. And hit enter, and we'll save that. And once we save that, maybe it wants it without the quotation marks. Oh, it took it out. Let's take the quotes off. We'll save that. And once we do that, a couple of things happen. The red squiggles go away, and we're now able to use address info. And we now have this other file in our change for this commit called ccpp-properties.json. And it just created this whole file here. Before there was nothing, now there's something. And in it we have our defines GNU source as one of our defines. So basically what this did was, now that it can find address info, if I go to definition here, address info is in here, and it's underneath this if define use x open 2k. So if use x open 2k is not set, then basically we get whole chunks of code not defined to us. And so we basically the compiler can do it, but we need to know, do we want to have that option enabled when we compile? And there's loads and loads of documentation. So if you're really interested, I do recommend you go read those couple of links I just showed and watch those videos to sort of get a better understanding. But okay, so we'll close these down. I'm going to close out of this UI thing now. We're good. And now GCC is letting us use this address info struct, which is a structure to contain information about address of a service provider. Let's take a look back at our code example again. Okay, so we have hints. We're doing a memset. So memset basically is a way of taking a pointer. So this is, you're taking hints by reference, and then we're zeroing it out for the number of bytes specified here. And we're getting that value from the size of function. So we're taking the size of hints, and that's the number of bytes we're going to zero out. And we're using the pointer to hints to do that. So this is a way of zeroing out, making sure everything is zeroed out before we start setting values. Okay, now we are not going to copy what was done here, but I do think it is worth pointing out how they're doing AF unspecified or unspec, which is allowing IPv4 or IPv6. Which, let's take a look at what we used here. We did AF inet, which is going to allow IPv4. Okay, so let's take a look at this. On hints dot family, right? Is it family? They're doing AF unspec equal AF underscore. There's unspec, but also there is inet. So there's inet IPv4 and inet6 IPv6. We'll see that in an upcoming video. But there we go. So we just set one of the members of this struct. Oh, by the way, I do want to pull this up one more time. So let me talk a little bit about what this is, if you're not familiar with C. A struct is just sort of a mapping of bytes. There's no memory associated with this yet. It's sort of like making a variable like an int. It's sort of like defining your own structure. So I'm explaining this really poorly. So this is a memory layout, if you will. So this structure is describing how this whole structure is going to be laid out in memory. So we're going to have an int followed by an int followed by an int, and those are all going to be back to back in memory. And an int is 32 bits. But keep in mind, when this struct is defined, we haven't told the computer yet to allocate memory for this. We're just saying this is the rule, this is the, you could think of it like a cookie cutter. This is the layout to follow when I do say create that struct. So this is the definition for that struct. And there's all of these different variables that get bundled up into a struct. So they're all just sort of bundled together. Now in our server code, we really are creating a struct. So now we're telling the computer, okay, hey, remember that thing? Remember that addrinfo struct? Okay, now I want you to actually make one and put it under the variable name called hints. And so once this line of code gets executed, the computer actually gives you memory that is exactly the size of this struct, enough space to have all of your ints in there, have this guy, whatever it is, it's going to have space to do that. And then what we're doing is we're using the dot operator to access each of them. So under hints, we're getting this guy, AI family. There's AI family. And that's why we're able to do that. So now we've said, hey, give us some memory. We've zeroed out that memory, and now we're going to start setting values. I just want to make sure it's clear what it is that we're doing here. So we're going to carry on here. They're going to talk about sock type, which is sock dgram. This is actually going to be a datagram for UDP. We're working on TCP in this video, so again, let's refer back to what was done over here. We're going to be doing a sock stream. What field is that for? For the sock type. Okay. Hints.ai sock type is equal to sock stream, semicolon, save. Sock stream puts us in TCP mode. Okay, the next thing we want to fill out is hints.ai underscore flags is equal to, and we're going to be putting this into passive mode, AI passive mode. So this is basically telling, this is going to set up our struct so that when it is read by the operating system understands, hey, create us a socket and we're going to be a server. This is literally saying, hey, this is a server socket. We're going to be using this for listening. We're going to listen for incoming connections. So this is AI passive mode. AI underscore passive mode, semicolon, save. What did the IntelliSense say? Socket address is intended for bind. Okay, and that's really all we're going to need. Now we are pretty much ready to use this wonderful get address info, except for one thing. Well, a couple of things. So let's go ahead and copy. Let's get this in there. Let's get this function in there. Copy, paste. Okay, we're not using command line arguments. If we take a look back over at server, maybe not. We're kind of on our own here. So basically what goes here, this is going to be our port number. So if we scroll up, the error message that it gives us, your argument count needs to be equal to 2. You're going to basically call the program and then specify a port number following the program. So that'll come in on arg v1. And so our port number needs to go on here. And we cannot use this define here because argv's come in as a character string. And this would be a literal 8080 number and not in a string. So here's what we're going to do. We're not going to worry about command line arguments right now. We're going to just simply put it inside a string like that using quotation marks and just type it in there like that. This is good. Null, that needs to say null. And what happens is this explains to us that how this function works. So let's go back up to the top. So we have a node, a service, our hints structure, and a res structure. So the hints argument points to an address info structure. We've basically coded that up. We're good to go. Okay, so if we are set for AI passive flag on the hints flags and node is null, then the returned socket address will be suitable for binding a socket that will accept connections. And this is exactly what we want to do. We'll just sort of ignore those other comments. That is intended to accept connections on the host's network address. Excellent. So if we look at what we did last time, we want to bind on the server and then accept connections on the server for that socket we're creating. This is exactly what we want to do. So the way this works is for the res field, res needs to be a pointer, and then when this function runs, node will be blanked out, service is provided, hints is provided. After this code runs, we're going to come back and we're going to see that our pointer was actually set to point to some memory that the operating system came up for us. So let's see it in action. So we need to create a pointer for result. I'm going to take the ampersand off here, and let's see. Oh, we do want the ampersand on, and let's see how they defined their result field on that examples. So result, there it is, structure address info result pointer. So we're taking the pointer by reference. So basically we're letting the operating system see where does our pointer live in memory. And then when we come back from this function, it is going to have results filled in. Very cool. So since we have GDB installed and GCC installed, we can use this run and debug feature where we're going to run our whatever file we currently have open on our screen here, that is going to be ran and debugged, and we can sort of step through this. So what we're going to do is we're going to set a breakpoint right here at the very start, and we're going to run and debug our code and see what happens. So it wants to know what configuration do you want to use. We're going to do a GCC build. I want to use just regular user/bin/GCC and debug active file. So we'll click on that. And right now we are frozen in time at this memset. So we have all these local variables. We have, we can see registers. I did not know that was possible. Wow, REX, Intel x86 instruction set. This is cool. Okay, so we want to look at a couple of variables. So I'm going to click plus on watch here. We're going to look at hints. Yeah, maybe we won't do it that way. Hints. Let's add a watch on this guy. If I scroll down. Add to watch. Okay. And results pointer, we're going to add to watch. I actually want the results pointer. I'm going to add the asterisk on there to watch. Don't know if that worked. Okay. So you can see that hints, let's lower the call stack, let's lower variables. So we can see that hints has a 1 for the flag, family is zeroed out, socket type has something crazy, protocol has something crazy, address length has something crazy. This has stuff in it. And we're going to do the memset. So let's step over the memset. And suddenly everything just blinked to 0. So we created hints using this, but the problem was that memory that we were given was not initialized to 0. So this memset zeroed the whole thing out, which is good. So now we don't have garbage inside this structure. And here's the structure. We got all this memory here. And then now we're going to start setting different fields of our structure to different defines from our library. So let's step over. We're going to set AI family. AI family is 0 right now. We're going to step over. Suddenly AI family is 2, which is probably exactly what this define is equivalent to on this system. So we'll step over sock type and we'll step over flags, and you can see those also got set. Okay, so now we're at this wonderful get address info, and we can see that hints has some stuff and results has nothing. And once we step over this function, suddenly results has something, and it's all filled out, and our hints was not changed at all. But results is now filled out with a bunch of stuff that the operating system told us. So this is pretty cool. And that is a simple look at debugging. So this is a really cool way to actually see how your different variables are getting populated with data. Okay, so let's stop the debugging and let's sort of get back into the action here. We've just done the get address info, which gives us this results pointer. Let's read about what does this results pointer give us. Oh wait, we already saw res will contain a suitable address for the bind. It'll return socket address that will be suitable for binding a socket that will accept connections. Cool. So let's go back down to the example and keep going. So they do this get address info, and then they check how did our results come out, and they give us this nice way to check erroring. Let's go ahead and steal that code. So let's bring this in. We brought that in, and we're getting a red squiggle on S. That is just simply because we have not defined S. So let's get the definition for S. Okay, so there is S. I'll take off the SFD for now. We'll save that. And if we go all the way to the top, we should be able to see what is returned, return values. So it returns 0 if it is successful, or one of the non-zero error codes. So the rest of them will be error codes. So we want to check if it was 0. That is exactly what this line of code is doing. We're capturing what was the returned number. And if it's not 0, we're going to exit failure and print out, hopefully, some helpful information. Very good. Let's keep plugging along with the example here. This is a comment. And then here, they're doing some very tricky pointer work here, but hopefully we can understand how it works. So let's go ahead and copy this and bring it in. I'm going to try to explain. So on our structure here, there is a pointer to another thing in a list. So every time we have this structure, the structure points to something at the very bottom. And what it's pointing to is another address info structure. So if you get through this whole thing and you decide, you know what, this one was no good, we can go to the next one and load this one up. Using this is going to be a memory location. We're going to load up that pointer. Suddenly we're looking at another memory location with more data and possibly with another pointer in the list. So that's what this is. Basically, they're saying, okay, the result pointer, whatever we got for our result pointer, let's make a copy of it into our own pointer. And then while the pointer is not equal to null, we're going to set it equal to the next pointer. So basically, every time we run through this code, we're going to the next one, just like I described showing this example. So if this one didn't work, load this guy up, and now we're looking at a whole new one at a different memory location. So that's what this for loop is doing. The next thing we're doing here is we are trying to call socket. And socket is going to be loaded up using the fields from our structure here. So AI family, AI flags, and AI socket type. Oh, and AI protocol. Those are the ones all filled out. So socket type, protocol for socket, and protocol family for socket. We're trying to create a socket using those parameters. And we're checking the result. If we got a -1, so why did they pick -1? Well, again, if we take a look at the man pages for socket, and we go to return value, on success, the file descriptor for a new socket is returned. On error, -1 is returned. And so just to really compare and contrast what we did here, if we go into what we did in the last video, when they create the socket, where is socket? Oh, that's the very first thing they do. They're capturing socket and checking if it's less than 0. So less than 0 is logically equivalent to exactly -1. So this is starting to make sense as well. So what does it mean if the socket failed to create? What does it mean continue? So what this is saying is if there's ever a continue, then basically you're saying go to the next iteration in the for loop. So continue means forget the rest of this, go set up your next iteration, and in this case the next iteration will be the next pointer, and start over. So that's what's going on here. And let's change this to say socket file descriptor, right? Because that's what the manual said it will return. A file descriptor for the new socket is returned. And that's all it is a file descriptor. So that's what we're going to use here. So this will not execute if we have something that is 0 or greater. And actually, we can change this to say less than 0. It is logically equivalent. So this won't execute. We're going to do something else. So what we're going to do is we're going to try connecting using that socket file descriptor. Is connecting what we want to do? I believe I may have copied the wrong bit of code here, right? Because in our example, here, this is the code I copied, but connect is for the client. That's my mistake. We want to be working out of the server program. They have very similar code here. But right here, this is the for loop we want to copy. So in this case, it's going to be bind. That is going to be the main difference here. It's still the exact same code. Everything is the same. So let's copy that bind right there. Copy. We will replace this. Very good. We will unindent that. Save. And we are going to be using our socket file descriptor. We're not going to be closing our socket immediately after binding to it. So let's take that off. We'll do that later towards the end. Here's the problem though, socket file descriptor has not been defined yet. So I believe that is just going to be a integer. So socket file descriptor, and we'll keep s the same. Very good. So now that error went away. Okay, so if if the return value of socket ended up being less than 0, we know that we can just try again with the next pointer. If our file descriptor is good, let's try to bind to that file descriptor. Again, we're using values from that structure that's from result, or from the linked list on the result. And if the bind returns 0, so if we go all the way down here and on the references, the bind here, we go to return values for bind. On success, bind returns 0. Otherwise, -1 is returned. So if we get a 0, then success. And break, if you're not familiar with the keyword break, break means we're done with this loop. Break out of this loop. Don't set up for another iteration. Don't start over. As soon as we see break, we're going to pop down here. Okay. So I think this warrants yet another debug session. So let's see what we get. I believe everything is looking good. So let's go to run and debug, run and debug. And here we are stuck right at this memset. And let's add another watch. Let's add our socket file descriptor. Let's watch that guy. I'm going to click add to watch. And and look at that. Our socket file descriptor has been created and it is not zeroed out. And while we're at it, let's also add a watch to S. And look at that. It gave us those variables and they are filled up with garbage. So these are meaningless values. We just by chance happen to get values that were not initialized. So keep that in mind. Okay, let's come up here. It says F10 allows you to step over. So I'm going to use the F10 key. I'm going to start stepping through this code. We can watch hints get changed. Oh, it already zeroed it out. And we're writing these values in for hints. Get address info. Okay, so when get address info is ran, we should see results sort of pop up with a bunch of stuff. So I'll hit F10. Suddenly results, everything was filled out for results by the operating system using this get address info function. Very cool. Oh, it looks like, oh, okay. Let me stop the debugging here. Let's get this guy out of here. That was copied and pasted in there twice. We need S equal right there. Okay, that's better. Let's click run and debug. And let's step through here. And then let's look at results. Get address info, that was done. And S was written to 0. So this whole if block will not be executed. I'll hit F10. And let's add RP to our watch. I'm going to collapse down result. And RP now is, what's the value of RP? We don't get to see the pointer. It's F0. Okay, so let's PF5. And suddenly RP has all of this data. And also look at that. The next pointer is pointing to nulled out memory. So, and that is exactly what is in result. Result and RP are matching. And then even, so if we try to load the next pointer, it's going to be equal to null, which is 0, and the loop will just end right there. Okay, so socket is being executed. Let's keep an eye on our socket file descriptor field. We'll hit F10, and socket is 3, which is greater than or equal to 0. So continue will not be executed. Let's try to bind to this file descriptor given to us by the operating system. And if the bind results in exactly 0, we're going to break out. Okay, so the bind was successful for this socket file descriptor. We're going to break and we're going to return 0. I'm going to click stop here and break out of that. Okay, so this is looking good. In terms of actually getting this code to run where it starts to step through this linked list, I don't have an idea on how to actually make that happen during debugging, and I don't think we really care that much. This is just kind of a cool little snippet of code that they provide to us for free of charge from the man pages. Okay, let's get back over to our example. Let's make sure we are looking at the server code. We're going to keep the client code the same. So here's the server code. We discussed how this for loop works, very interesting. And then they're doing this close on the socket file descriptor. We're going to save this for the very end. And as a matter of fact, let's just go ahead and put that at the very end right now. And let's see how we were doing back in video 1. So they create the socket and they put it on the file descriptor. Then they're doing the set sock opt. We don't need to do that. And then they're doing some other stuff. And then they're doing the bind. We don't need to do any of that. We're doing the bind our way, and we are all done with the bind. So what they do next is they go into the listen. The next thing they do is they listen using that server file descriptor. So they're going to listen for incoming connections. So let's look at the man pages for listen. So here it is. Let's take a look at the example. Oh, yeah. Before I move on, we sort of don't want to listen to what the example is doing from here, just because they start talking about doing it for UDP, and there's all sorts of nonsense that we're not ready to discuss in this video. We'll discuss in an upcoming video. So let's just ignore them now, and we're going to start going our own way, because we're going to recreate what was done in the last video. Okay, starting with listen, and I already see they have a wonderful example here. Let's take a look at that. See bind. Let's see, do I already have a tab open for bind? I do. So here we are on bind. Let's go to the top and let's go to the examples. Okay, so what are they doing in this example? They're going to make an internet domain socket. And this is going to make a stream socket, which is TCP, which is what we're doing in this video. And they're going to be doing it for the Unix domain, so a little bit different than what we're doing. So let's see, they have listen backlog, and they have my socket path, some path. Okay, yeah, so we'll keep going here. This was a little bit interesting, but we'll explain that in a second. Let's look at their example. So they are using sock address UN. Let's just ignore them for now, and let's get down to, okay, here's their bind call, and then they're doing error handle bind call, and here's their listen. So they're going to listen using the socket file descriptor, and if it's exactly equal to 1, equal to -1, then we are going to handle that error. So let's copy this code in. Copy. And let's get back over to video 2. Instead of SFD, we're working with socket file descriptor. We'll just fix that error right there. And paste. Oops. Got rid of my copy. And paste. Okay, so we're going to listen on socket file descriptor. This listen backlog is getting the red squiggle. So that is this preprocessor definition. Let's go up there and paste that in. We're not Let's see if we can try this. I don't know if that works. I think maybe it does. I don't see why it wouldn't. Okay, so we might get an error thrown because we did that, but we'll find out. Okay, now listen backlog is no longer complaining. Okay, so we're going to run this function, and if it is exactly equal to -1, we're going to do this error handle. And then let's see what we did in the last video for listen. What did Geeks for Geeks do? So they're doing if, and then they're running the listen function. If it's less than 0, they're going to run this code. But either way, whether the stuff inside the if statement runs or not, the listen function got executed and the listen function was completed. If it failed, this code runs. If it didn't fail, we move on. So that's what they're doing here. That's what we're doing here as well. But let's talk about what this error handle thing is. So this looks like a function somewhere, but it's not. It's actually a preprocessor definition. And what does it do? It calls p error on the message provided, and then it does exit failure, and it does it in a do while loop, which is strange to say the least. We don't need to do that. We can just copy these 2 lines of code, and we can put curly braces and paste. Very mysterious. I don't know why these examples do mysterious things. And then, this MSG, that's provided by the argument. So we'll cut that. We'll paste that there. And what did we just make? We basically just created, let's go to the split screen view. Can I minimap? It's much better. Okay. We basically just recreated what the Geeks for Geeks did. They're hard coding the 3. We have it on a preprocessor define, which is nice because then at the top of the code you can change it. We have ours at 50. They're saying less than 0. They're saying exactly equal to -1. I sort of like the logical equivalent more than saying exactly -1, because what happens if it's something else? You should never assume you're going to get what you're going to get. Yeah. Okay. And it's basically the same code. So Geeks for Geeks code is exactly what was on the examples over on the man page, except the man page sort of did it in a fancy way. Okay, and then they have a comment here, and they're saying we can now accept incoming connections one at a time using accept. So listen basically says, okay, that socket, the socket file descriptor, we're going to listen, and we're going to listen for this many people that come along, and these people that come along, they're all going to be all the clients are going to be getting into a line, and every time we say accept, we're going to take the next person in line, and something can occur where what is listen set to? 50. So if we have the 51st person get in line and we're going too slow, the server is not able to keep up. If the 51st person comes along and they try to get in line, they're going to get a connection refused. And this is sort of how I believe DDoS attacks occur, or denial of service, where basically you just fill up the line on the server and the server can never keep up. Okay, so what are they doing? They're calling accept on the socket file descriptor. They're taking the next person out of line, and then they're capturing the value of accept, and they're checking if it's -1, then we're going to error handle accept. And we already know error handle is basically just p error exit failure. Okay, so let's copy all of this code and see how it is different or equivalent to what was done in the last video. So we already know that SFD, that is actually socket file descriptor. So that is fixed. CFD, this is going to be our client file descriptor. And I don't think we have a client file descriptor yet. Oh, how do I know that it is a client file descriptor? Well, let's go take a look at the accept. Here we are in accept. If I go to return value, on success, it will return a file descriptor for the accepted socket. On error, it is -1. So that is our client file descriptor. And if it is anything less than 0, then we know that we need to error handle accept, which is just flat out this code with this text changed. We'll get rid of error handle. I like to write my if statements like this. Save that. Client file descriptor is still complaining. Well, this is just going to be an integer, and we can verify that by checking the example back on the bind man page. It is just a int. CFD is just an int. Client file descriptor is just an int. So let's paste that in there. We'll change this to client. Cool. That fixes that. Okay, what's going on with this business? Well, let's see if we can find out what this is supposed to be. Well, I know this right here. Well, okay, so here's how we figure out what this is supposed to be. Let's go take a look at the man page for accept. And let's go all the way to the top. And what are the arguments? Well, we need a socket file descriptor. We need a ADDR and an ADDR len. And let's figure out what these fields are. So accept is a system call, connection-based socket. You can use it on SockStream or these guys. It extracts the first connection request on the queue of pending connections for the listening socket described by sock file descriptor. And it creates a new connected socket and returns a new file descriptor referring to that new connected socket. The newly created socket is not only in the listening state, is not in the listening state. The newly created socket is going to be, and the original listening socket is going to keep doing its job. It's going to be unaffected. So the newly created socket is not in the listening state. Well, what state is it in? The ADDR argument, well, okay, so I'll give you a spoiler. The newly created socket is not in the listening state because it is our client and we're ready to start communication with this newly created socket. Meanwhile, our old socket is still listening for new clients to come along. Okay, I just wanted to throw that out there. Okay, this is what we're curious about. ADDR pointer to a sock ADDR structure. This structure is filled in with the address of the peer sockets as known as a communication layer. The exact format of the address is ADDR. When ADDR is null, nothing is filled in. So ADDR is going to be the, where does it say it? Okay, so ADDR is going to be a sock ADDR structure that is filled in with the address of the peer socket. So this is going to be a structure, a sock ADDR structure that's going to be filled in with the peer socket. Now, I happen to know of something very specific over on the socket man page. If I can just find it. Let's do a find on sock ADDR. Okay, on socket 7, it says this. To allow any type of socket address to be passed to interfaces in the sockets API, the struct sock ADDR is defined. The purpose of this is to allow casting of domain-specific sockets to a generic type to avoid compiler warnings about mismatches and calls. In addition, the socket API provides the data type struct sock ADDR storage. This type is suitable to accommodate all supported domain-specific sockets. It is large enough and is properly aligned. So we want to be able to support all domain-specific socket address structures. And so this one is going to give us the best compatibility. So with that said, let's start to fill this out. We're going to define a struct sock ADDR storage client client ADDR. Save. So we're going to get the size of it, and we're going to tell the accept function the size of our storage area that we have ready to go. And we're going to give it a pointer to our storage, and we are going to cast that pointer to a sock address, because that is what the that is what the function is expecting. Okay, so this is looking good. What comes after the accept? Well, this is where our server-side code comes in, where we basically read, and I noticed that val read is actually used nowhere in this entire code other than to define it and populate it. So we're going to get rid of val read. We'll copy this server-side code, what we do with a client when they come in. We'll paste it in there. We will get rid of val read, and then read new socket. Nope, this is actually our client file descriptor. So the socket for our client, the file descriptor to our client socket. And we need our buffer and our hello to come back. So we can get those to come back. There they are. And we'll put it right there. There they go. Save. And then close socket file descriptor. Oh, sorry, I did not mean to alt tab. We're going to close the, we're going to actually do a shutdown, which I do kind of like. And then for close, we're going to close the client file descriptor. So we'll save that. And there we go. We've now basically rebuilt and improved the code that we got from Geeks for Geeks. Let's see if it works. So now that all this code is in here, let's go ahead and build the code. Control-Shift-B to build. Things are looking good. Let's run it. I'm going to use this play button up here. I'll click Run C++ file. And if I expand out this terminal. Oh yeah, so it doesn't put any messages out while we're waiting. It is just sitting here waiting for a client to connect. So let's jump over to our client machine. And let's get into our network programming ls. Let's get into video 2 ls. And we're going to gcc client.c -o client clear ls. Now we have this client executable. I'll /client, hit enter. Hello message sent. Where did we send to? And then it quit. And accept bad address. Oh, what happened? I think we need to fix this warning here. It's actually expecting socket type socket len t. So when I hover over this warning, it's looking for sock len _t. Sock len _t. Let's call this client addr len, and we'll do size of like that. So now this is starting to look exactly like what we had on the accept. What are we working on? Accept. The accept example. Cbind. The accept example. Accept. Created a pure addr size sock len t. So let's do it exactly how they did here. They pass it by reference. So let's do that. So client addr pass by reference. Let's give that a try. Save that, build that. Control-Shift-B to build, and we'll run that. Now we're waiting. Let's go to our client machine and run the client, and now it is working. We have our hello message sent, and then the hello from the server. Meanwhile, over here, hello from client, hello message sent. Very cool. So now, just for fun, let's get this server code on a real server out there on some data center owned by Microsoft out there in the wild, wild world, and we're going to connect to it over the real internet from our client and see this server code in action, this new and improved server code where we've actually went through absolutely every single thing that this thing does. So let's do that. So I need to just close this guy. I still have my client here, and I have my virtual machine here, and we are going to VI. Well, before we VI, let's do sudo apt. Link is in the description. This is also in the previous video. Sudo apt get install build essential, and we'll say yes. We'll come back when this is done. Okay, and we're back. I'll hit clear. Now we're going to vi server.c. Going to switch back over to our Visual Studio Code. I'm going to hit Control A and copy. I'm going to come over here and hit I for insert and right click, and there it goes. I'll hit escape WQ, and we are going to gcc server.c -o to the server executable, and we have server right there. So I'll hit /server, and it is running and it is sitting there. The other thing we need to do is we need to jump over to our Azure virtual machine, and we need to go down to networking. We need to open up port 8080. So add inbound port rule. Source port ranges, anybody, destination, any service custom port 8080 any. So we'll open this up, we'll add that. This will take a second to load. Okay, security rule created. While that is still setting in, we're going to copy this public IP address. We're going to come over to our VS Code on our local system, and we're going to look at the client code, and instead of 127, we're going to change that IP address to our public IP address here and save that. Now that that is saved, we need to, that is the server running and waiting. The client, we need to build the client again. And let's try running the client. And there it goes. So over on our server, we have a hello from the client. Hello message is sent. And over on the client, it's the same result from the last video. I hope you found this interesting. I hope you learned a lot and got some interesting information. I hope you also learned some C++ and C programming. We're still kind of getting into the basics in this series, but I hope to expand on this and do lots of very cool things in the near future. Thanks so much for watching, and I will see you in the next one. Take care. Bye-bye.